For this set of problems, we're going to be taking a look at some graphs and determining the domain and the range. Remember that the domain, those are your x values, and the range, those are your y values. For our first graph, we're going to take a look at this one. So to take a look at a graph and come up with the domain and the range, what we want to do is take a look for the domain, how far to the right and how far to the left this graph goes, and if there are any breaks in the x values. So our x-axis goes left and right, so the domain, that tells us which x values work. How far left and how far right does this go? Well, this graph does go forever to the left, and as you're looking at x coordinates, here like this point would have an x coordinate at -9, -8, -7. We have all the decimals in here too. Here's like -2, -1.5, -1. So you have all of these x values, and it looks like our graph is going to get very, very, very close to the x-axis. As the graph goes upward, it's getting closer and closer and closer to the x-axis. So for this left section of the graph, the domain would be as far to the left as we can go, which would be -infinity, and all of the numbers would be filled in all the way over to really, really close to the asymptote. So from -infinity over to an x-coordinate right next to the asymptote, which would be at 0. So for the first part of our domain, our graph is going to be going from -infinity and getting very, very, very close to 0, but not touching it. If it touched 0, then we would want to bracket there, but we're just going to get close to 0. So for this left section of our graph, we are going from an x-coordinate of -infinity over to as close to the x-axis as we can get. The graph picks up again over on the other side of our y-axis, so it's starting with an x value very close to 0 again, but this time going forever to the right. So as you kind of scan this from left to right, your domain is going from -infinity over to 0, but doesn't include 0. And then it picks up just after an x-coordinate of 0 and goes all the way over to the right. So there are two parts to our domain. We have the left side of our graph, which goes from -infinity to 0, and then from 0 to infinity. Basically, everything except for 0 is represented on the graph with an x value. So that is our domain. For our range, those are our y values, we'd want to take a look at the graph and see how far up and how far down this graph goes. Well, if we start at the bottom of the graph and kind of work our way upward, the lowest point that we have is actually on both sides, it's the same, and it's just barely above the y-axis. So on the y-axis, that would be a height of 0. We're starting just a little above that, so greater than 0. And then the graph goes all the way up. We do have a lot of repeated y values there, but that's okay. The lowest point on our graph looks like it's something just bigger than 0, and then our graph goes up for forever. It doesn't include 0 because it doesn't look like we have any points that are going to be on the x-axis. So there is the domain and range for that graph. For our next graph, we're going to be taking a look at this one. So again, we want to do the domain and the range. So we want to take a look how far to the right, how far to the left does this graph go. If we scan this from left to right, there's no points out here. There's not a point until we get to an x-coordinate at -3, and it's a closed circle. So -3 is included in our answer. So the first point we get to is at -3, and as I scan this from left to right, we have all of these points on our graph until we get over to an x-coordinate of 3. All the values in between here are represented by all of these points. And we have a closed circle at -3, so that is included. And we have an open circle at +3, so that is not included. So for the domain on this graph, We are starting on the left side at -3, and we want to include that because it's a closed circle, and then all of our x's exist until our graph goes over to the right and stops at 3, but it's an open circle, so we do not want to include 3 in our final answer. For the range, scan your graph from bottom to top. We don't have any points down here. The first points that we get are these two. This one is at a height of 0, and so is this one. This one's not included in our graph, but this one is. So there is a point that has a height of 0 with the closed circle. And then our graph, as we go up to the top, all of the points are represented in their heights from a height of 0 up to a height of 3. And that is also inclusive. The regular part of the line are like a whole bunch of closed circles. At the end, we tend to exaggerate those, but this closed circle dot right here is just the same as all the rest of these closed circles. So we have a point at a height of 0 all the way up to a height of 3, and we would like to include a height of 0 and a height of 3 because those are closed circle. For the range, we are going from 0 to 3 inclusive. Going from 0 to 3, including 0 and 3 for the range on that one. For our next example, we'll take a look at this graph right here. So again, we want to do domain and range. So scan your graph from left to right. And there's no points here, but we have to assume that this graph is going to continue with the behavior it has as it reaches the edge of the page. So this graph is mainly going downward, but it is continuing to go to the left. And if we continue down this graph would go forever downward and forever to the left. As it goes down, it goes to the left, and it's going to keep doing that. So even though it's really steep right here and it mainly looks going downward, it is going over to the left a little bit as we go down the graph. So this would continue to go all the way over to -infinity. Eventually, if we let the graph go down far enough, the graph would go over to the left for forever also. So our domain is from -infinity, and all of our points are included from left to right. And again, as we get to this side of the graph, this graph is going up here, but as it goes upward, it's going to continue also going to the right. So there's no breaks in this graph at all. This graph would go forever to the left and go forever to the right. So our domain on this one is all real numbers. It's everything from -infinity to +infinity. When you scan that graph from left to right, you would have all of the values there. Similarly, the range. This graph definitely goes down for forever and definitely goes up for forever, and it does have some overlap here. For instance, there are 3 values that are at a height of 0, but that's fine. We just would make sure we include 0 in our answer. So from -infinity up to +infinity, also for the range, or all real numbers for that graph, for both domain and range. The last one looks like this. So again, we want to scan our graph from left to right. What's happening on our graph with our different x coordinates? Well, this graph definitely goes over to the left as far as it can go. And we have all these x coordinates, -6, -5, -4, -3, -2.9, -2.9, -2.8 rather, -2.7. We keep going, here's -2. We keep having all these x coordinates, and it looks like our graph is going to get closer and closer and closer to the y-axis, but never quite get there. And then it picks up at the top of the graph, but also just over to the right of our x-axis. It looks like we probably have like a vertical asymptote on top of the y-axis. So our graph goes from -infinity over to 0, and then on the other side starts at 0 and goes to the right. So kind of like that first example we looked at, there's 2 parts to our domain. There's the left part, which goes from -infinity and then gets close to an x-coordinate of 0, and then starts up on the other side of the y-axis and goes from just over to the right of 0 and then forever to the right. For our range, this graph definitely goes down for forever, and it goes up, 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 but as it approaches the x-axis, it does slide off to the left here. But in terms of height, we have all of these points that are here, just not up at a height of 0. And then once we get on the other side of the axis, same thing. We're starting here with some points that are just barely bigger than 0, and then our graph goes upward. So our range values on this one, our graph starts at the bottom and goes up and gets close to the x-axis, and then begins just after the x-axis, and then goes up for forever. So our domain and range happen to match on this one too. That does happen on a few problems because of symmetry and some other things, but as you go through and do these, the domain and range, you want to scan these from left to right. Take a look at what values are there. You do have to make some assumptions about what's happening as you get to the edge of the graph and what's happening, and with the arrows on the edge, what's happening to the graph, where is it going? You can assume that the behavior that you're seeing is going to continue, and we should use those to come up with our domain and our range.